Hello, everyone. My name is George, call sign N3VQW. Most of you know me, but just in case you don't, I've been a kind member for like about 6 years now. More than that? I don't know. Been pretty active in the club. This is probably my fifth presentation I've done. But basically, I came to Chesney with an idea, for a topic on 3D printing, and he said, "Can you do July or September?" So how it works.
Here we are, September, right?
If we can. There's no August. All right. What is a 3D printing? 3D printing uses computer-aided design to create three-dimensional objects through a layering method, sometimes referred to as additive manufacturing. 3D printing involves layering materials like plastics, composites, or biomaterials to create objects in a range in shape, size, rigidity, and color. It's stolen off of Google, by the way. What is, 3D printing technologies has existed for decades. However, the advancement in lowering cost technology has made 3D printing affordable and practical to the masses. It's really inexpensive now. A few $100 and you've got a machine that can do quite a bit. Here's a little picture, shows a part for one of my radios that broke, and I was able to completely create a new part, and because it wasn't available, and fix the radio. Why use a 3D printer? Well, there's several reasons. You can inexpensively build prototypes or test the parts that you plan to mass produce. 3D printers are not very good for mass producing because they're slow. That part I just showed you took about 9 hours to print. So you can use it to make prototypes to test the parts that you plan to mass produce using injection molding or other methods. You can make replacement parts that are not easily available or cannot be purchased. You can make custom parts for hobby projects, and it's also fun designing and making things. Once you have a 3D printer, you're always finding things to print. You're doing some repairs around the house and make new components. Like I have a little bookshelf shelf holder. That's one of the first things I designed when I got this thing. Is I have a bookcase, but all the shelves are being held by the books, and they have the holder. So first thing I did was made those. Here's Kitty. We all know her. She's testing out a 3D printed knob I made for her antenna switch, and that's floating around somewhere out there. There are the two most common types of 3D printers: fused deposition modeling, or also known as FDM, utilizes polymers as a raw material in the filament form. Filament is usually heated to a molten state and then extruded through the nozzle of the printer. It's cheap and affordable. There's a wide variety of printing materials in different textures, solidity, and colors, and it is the most commonly used 3D printing technology. I'm also mentioning there is a stereolithography SLA, which uses UV light or lasers as a light source to selectively cure polymer resins. Those printers tend to be a bit more expensive and smaller prints. They can do larger prints, but those are more expensive. They create extremely highly detailed parts. So if you're wanting to make in-scale model train stuff, that'd probably be a better approach. This does require use of toxic resins and requires post-processing to cure the resin. So you need another piece of equipment to actually harden the plastic. So you have one to print, you have one to finish it. This presentation will focus on FDM printers, which is the easiest way to get started, cheapest way of getting started, and it'd probably be the most useful for use in making stuff for your home and hand chat. How an FDM printer works, and by the way, this is an FDM printer. The filament comes on spools. I have a couple examples here. So it's this is a 1 kilogram of plastic, and just to let you know, this costs roughly $20. Some of the plastics are like 15, some are a little higher. This is a Microcentric brand, which works really well. So the plastic is put into a heating element, so it follows up into the heating element, pushed into there, and it's melted right in the head of the nozzle. And then the nozzle goes and it actually layers, prints along a path, depositing a set amount of material, thickness, and temperature to produce a 3D object. Materials. PLA, polyadic acid, is the most widely used filament because it's the easiest to print. This plastic is made from vegetable starches, having the property of being biodegradable, and that's in quotes because it's not like you leave it outside, it's going to melt right away. It will take some time, and being able to melt at low temperatures. This is not a good material to use for something that goes in your car or outside. It will melt at a low temperature. So keep that in mind. We'll get to material that's much more recommended. ABS, and forgive my pronunciation of these words, I'm not a scientist. Acrylbutane styrene is especially valuable in strong plastic parts that must remain resilient in the face of temperature swings. To print this material correctly, it is necessary to have a closed printer to maintain the heat during the print. Another factor I didn't write down here is you must have good ventilation. You know what burnt plastic smells like? Well, the fumes from it, that's what you're going to get. It can be quite unhealthy to print ABS in a non-ventilated area. It is a widely used plastic in industrial applications. It's very strong and it's very heat resistant, but it's difficult to print with because your air, if it's not encased in a container, cold air is going to blow onto your print. It's going to cause it to malfunction or do some bad things. So there is a compromise, a newer plastic called PETG, glycolized polyurethane PETG. Yeah, PETG is an intermediate between PLA and ABS. This plastic has a good mechanical strength and is a good chemical resistance, and in this addition to be easy to print. They say it's almost as easy to print as PLA. Now, the thing about the PETG is it requires a slightly higher temperature than PLA. With the PLA, the Microcenter brand is about 215 through 230 degrees Celsius. I use 220 degrees Celsius. This requires a range of 225 Celsius to 240. So probably somewhere in the middle is the sweet spot. That gets close to this thing's maximum temperature that you want to operate at, because this has some nylon parts that can start to melt at those temperatures. You can do it with this printer, but it will shorten the lifespan of some of the parts in this printer that will need to be replaced. So one of the things you can do is you can get a printer that has a direct fed mechanism, and with this printer you could buy, this company makes the part. So instead of this filament going into this little device here that pushes the filament into the nozzle, filament just goes directly into the nozzle. And with that, you can print higher temperatures. Another thing is you print materials, other materials that can wear down your equipment much faster, like certain metals, certain polycarbonates, rougher materials. Yeah, nylons, things like that.
Carbon fiber reinforced nylon that eats head like a freak.
Yeah, the head that comes with the printer is made of brass. A good recommendation is to upgrade that to a hardened steel head, because these components will wear out over time. And you're doing higher temperatures, of harder materials will wear it out quicker. So that's one of the things about the 3D printers is some of the components are consumables, like the wheels, they'll eventually wear out. And here's a picture assortment of benchies. This is a test print. It's a standard test print. It's very popular. You know, everybody prints these because this tests your printer's capabilities. Because you can see there's different angles, there's circles, there's portals. There's areas where it's printing over nothing. And to be able to see how your printer's calibrated to be able to do that, this is just a standard test with a known result.
So I print one 3D printer obstacle course.
Yeah, it is basically. The boat is designed very specifically the way it is. Doesn't float with the darn though. So, yeah, you put it in water, go. So
how long did it take you to print that?
what? Yeah.
How long did it take to print that one?
This one about an hour. of this size, a little more an hour, maybe an hour and a half. And I printed one for each color I have, and I have like a 13 or 14 different colors. I brought the purple because I thought Pat might be here and she likes purple. Hey, where do I get things to print? Well, you can download things that other people have designed from websites like Thingiverse. Or you can design your own things using a CAD program. That, by the way, Steve's knobs that I printed for him got right off of Thingiverse. I went to Thingiverse, typed in his radio model, and somebody had already designed the knobs for it. So it just took my printer half an hour to print, and he's happy.
You can also download somebody's model and then modify it.
Yeah,
I've done that before.
some of the models are actually intended to be modified.
And just for a reference, Thingiverse has over 10 million objects so it's out there.
And people keep adding to it. I've added stuff to Thingiverse.
Yeah.
Search, don't browse.
Oh,
So,
the other thing on Thingiverse is you do have to pay attention to the license. Some items are Creative Commons, some things are not Creative Commons for modification and distribution. If you plan on modifying something and then distributing it, you need to be very careful with the license of your file. Because some things are Creative Commons, some things are not.
So the left picture here is of a antenna mounts for a arrow antenna on a tripod. That's one thing you print. You can actually print arrow in the antennas, all the non-conductive parts. You can make antennas like that. In the right picture is that knob I made for Kitty. That's in the CAD program. Ideas of things to print. 3D call signs is one of them. Yes. There's one of those little dead guys floating around somewhere on the table there. If the desk signs with your call sign on it, ham radio 3 themed ham shack decorations like AR logos, your club logo, all kinds of decorations. Custom cases for your projects, and I noticed that some people have brought some of their 3D printed cases. I brought one for Raspberry Pi. This right here is a Ubitix radio case for that, and there's actually quite a number of Ubitix radio cases out on Thingiverse. Here's somebody who made their own little power pole distribution box. That looks like an interesting project. I mean, you could go and buy one, but if you have all these power poles laying around and an hour's worth of work, you can. Mic holders, radio stands, the dashboard mounts, belt clips, and knobs. Knobs are fun and easy to create. Loading coils, insulators, balance. So there's all kinds of antenna parts. This saves you from having to take that trip up to Hamilton to, buy little insulators there. You can also make antennas themselves, at least the non-conductive parts of them. And I'm probably going to make one of these myself. Just get this little thing, run the wires in here, and I have plenty of these connect up PL259 connectors. Here's a dipole someone made.
I'm in that Zoom meeting.
What was that?
Somebody on.
Now, you do need some software. If you're going to design your own designs, you need a CAD program. Now, I use Autodesk Fusion 360, which is free for non-commercial or paid $70 monthly is the lowest subscription they have. There's another program out there called SolidWorks. It's a minimum license for home use. It's not free. It's like $10 a month. So SolidWorks is, yeah.
If you're looking for something that's a little less detailed, a little bit more new user friendly, Tinkercad.
Yeah, that's a web-based, yeah, there's Tinkercad, and there's also this OpenCAD, but I opened it up and I had no idea how to use the thing. It was like, yes.
One note on Fusion 360, it is usable for free for commercial use up to $100,000 in sales. That's in there, you look.
Yeah. As a hobbyist, you're with the free license, you're limited to certain amount. I think it's less than 100,000 actually.
They may have edited that.
They changed it.
Last time I looked. It was-
Yeah. And you're with the free edition, you're only allowed to have up to 10 editable objects in your library.
Yes.
But when you're done with something, just change it to read only and then you can have more. And you can always change from read only back to editable. So, there's a workaround for that. The Autodesk Fusion 360 is a cloud-based application. It is a desktop application, but it saves your files online, and some of the features like converting the files and stuff are done on their servers. And the software is available for Windows and Mac. Now, once you get this, your CAD drawing, whether it's Thingiverse or you design yourself, you need to be able to get it to your 3D printer. So you need what's called a slicer. And that's what converts the 3D object into the print of the print job, basically. So the slicer is that came with this printer, and a lot of people use Ultimaker Cura. It's free. There's no, it's free for everybody. Supports many models of printers from many manufacturers. So if you have a 3D printer, chances are Cura will work with it. There are other slicers out there. Some printers have their very specific slicer that you have to use, but for most of the commercial 3D printers that you buy, Cura will work. And that's
It doesn't have that money issue the other thing has.
no, it's completely free.
And it's completely open source.
And yeah, it's also open. So how to print a thing. If you download your thing from an online source such as Thingiverse, you'll usually get a zip archive containing one or more STL files. Each STL file contains a single part of the thing or different variations of the thing. Example, you'll have an STL file for the bottom of a case and one for the lid. Or you can have, like for example, this rocket here. You have one that's this size, and you have one that goes on to the bigger size. So different variations of the same things. If you design your thing in a CAD program, you will need to export your design to an STL file. Fusion 360 will do that in the free edition, but you have to be online to do it. Next, you need a slicer program to generate the G-code file from the STL. The G-code file is what the printer understands. It's an industrial standard. And the G-code file contains step-by-step instructions for your specific printer to print out the thing. And instructions are X, Y, Z movements of the extruder and the bed, temperatures of the bed and the extruder, flow rate, support structures, filament change points, etc. So it's the instructions that goes to your printer. The G-code file is specific to your printer. So if you want to share your print with somebody else, send them the STL file, not the G-code, because the G-code file for this printer may not work properly with another printer.
What part of the tool chain as the support structure that was needed, like if you had a piece that was so.
The slicer program will automatically do that.
Well,
And I'll cover that when I demo the slicer program, okay? And there's different types of support structures. Cura actually came out with a new support structure design, which makes it a little easier to break apart because you're printing something that has a huge overhang. Obviously it's going to start to sag, so you'd have to have something underneath it to hold it up. And downside about support structures is it does use up plastic. So when you're doing 3D printing, you start to have a nice little collection of material you basically have to throw away or recycle. Where do you get your 3D printing supplies? Well, we're very fortunate that we have a micro center nearby because that place is awesome. Okay. How many of you have been to micro center? Okay, if you have never been to micro center, lock your wallet in the car because you're going to be
You're going to leave with something.
yeah. They have a whole maker section where you buy electronic components and things like that. They have 3D printing section where they have all kinds of 3D printer models. They have all the parts for 3D printers. They have the filaments. They have and then the cool part is they have like 20 models on display, and you could tell that they're actually actively using these display models to print crap. And you go in there, and you see all these 3D prints that the employees have done. You see the wear patterns on the face plate. So those employees are allowed to have fun at work with those things. And I went there Saturday and they had this huge printers like this wide and that tall, and they were printing off a Mega Man helmet or something, you know. And so this, the manager says, this is going to take several days to print. Hopefully it doesn't fail, you know.
Spaghetti.
Yeah. So, and I was like, how much does that printer cost? $900. But the thing's like, just.
George, have you ever seen the print mill running?
I haven't seen it, but they have one that looks like a cat treadmill.
Yeah.
So you can print a really long object.
And you just continuously print, it's called a print mill.
So anyways, they have, Micro Center has their own brand of filaments, and it works really good. I don't actually remember what the actual brand is, but it's some other manufacturer that Micro Center has contracted. And yes,
It's sunny.
okay, yeah. And it's good stuff and it's inexpensive. $15, $20, $25 for 1,000 kilograms of.
Believe it or not, it's actually cheaper than Amazon. If you buy
Yeah.
the Sun E direct from Amazon, you'll pay more.
And you go there, and if you've been to Micro Center, you see how long their aisles are. Well, it's an entire aisle on one side of filaments and an entire aisle on the other side. So there's,
Their sparkly filaments are a little bit, the inland ones, the sparkling ones are a little bit finicky, but making print.
you keep in mind the sparkling ones also where you print head out.
Yeah.
Too.
They're abrasive.
White.
I thought glow in the dark filament, which is again useful for parks on the air, because if I'm off the dark.
Yeah.
And I need to find something, take your flashlight, wave it in an area, shut off your flashlight, it'll pick up enough to give you the glow.
Especially if it's snowing, you but like charging.
Yeah.
Yep.
All right, so I'm going to, can I switch or do I have to stop my shared switch? Just click on this, and then I'm going to say screen share. I'm going to share Autodesk Fusion 360. So the reason why I'm going to demo Autodesk Fusion 360 is because it's the only one I know how to use. Like I said, there are other programs out there. If you're familiar with what's the name of it? SolidWorks, use SolidWorks. If you're familiar with Tinkerverse, even I think even Google Sketcher can be used.
Microsoft Sketch can be used.
Yeah. But by the way, Windows 10 and above supports, they have a 3D viewing application. It supports the STL file. So you can actually open it up and view it without needing any special
If
software.
it can export STL, you're good.
Yeah. All right, so as a quick demo, we're going to do a knob. Okay, we're going to design a knob. And this is a very practical one because pretty much everybody has at least one radio that's missing a knob sometime in their life, right? Okay, like him. So basically, you start off making a 3D object using 2D drawings called sketch. So I'm going to tell it that I want to create a sketch. And of course, this, let me minimize this little control thing for Zoom here because it's in the way. So I'm going to create a sketch. So under create, so you have create, modify, assemble, etc. I don't know what half this stuff does because I never used it. Create sketch. And I want to put it on, see this little 3D box here? I want to put it on the front plane. So you can see here it says front, right, top, go here. And what I'm going to do is somewhere around there. A big knob, here it is. My problem, we're making this knob only much smaller. What we're going to do is picture this cut in half. You're just looking at it forward. I'm going to draw the two-dimensional shape from the halfway point in the edge. Okay. I don't have to draw a 3D knob. I mean, you could, but sometimes it's easier to start off with a two-dimensional shape. So I'm going to start off with 10 millimeters. I'm going to start in a line, type in 10. And that gives me a good starting point. It gives me the idea where to zoom to, because I don't want to create something really large and have to shrink down and then get kind of lost in. So I'm going to now just draw the basic shape. And I'm just going to double click the finished shape. We'll use what's called the distance tool to measure out the different sizes. This one's gonna be 4 millimeters. Now, this is gonna be a tiny knob, but the reason why I'm doing a tiny knob, so when I do the demo print, it doesn't take 30 minutes. Okay, so this is gonna be 5 millimeters, and I've already planned out these sizes so that the demo will go smoothly, and I've done this 100 times in practice, so hopefully. So 4 millimeters, 5 millimeters, 3 millimeters, 5 millimeters, 10 millimeters. So we have our basic two-dimensional shape looking at the knob from the front, or from the side. Okay, going to finish the sketch. And going home, it goes back into kind of like a three-dimensional view. Now, how I'm going to create the 3D object is I'm going to rotate that shape around an axis. So there's a tool here called the revolve tool. It automatically selects my two-dimensional object because it's the only thing there. And I'm just going to basically click on the inside edge and it
Set your
creates,
access point.
yep, it creates the knob. We're done. I'm just kidding. Now I'm going to do is I'm going to add a little rounded edge called a fillet. And now I'm going to say 1 millimeter because 2 millimeters is going to be too large for the small print. And realistically, 1 millimeter is going to be too small for it to really show up on the print anyway, but I like to use rounded edges.
The hole in the middle of it for it to go over something.
Yeah. So anyways, now we got the round edge. Now, what I want to do is I want to create these little grooves here for, you know, a little texture. So I want to put them on top of the knob. So I go to the top, create new sketch. I'm going to zoom it a little bit, and I'm going to create a circle. In this case, it's going to be a 2 millimeter circle. Just going to conveniently match up with both edges, the inside circle and the outside circle. Now, I could have the option of drawing a circle manually going all the way around to create this pattern, but funny enough, they have a circular pattern tool, so I don't have to do that. I just select the circle I created and create a circular pattern. I'm going to select the center point, which is the center of the circle. Hang on a second. Undo that, select that. Select the center point, and as you can see, it has 3 circles now. I'm going to tell it I want 10 circles. Now, do I know it's 10 circles? Because like I said, I practiced this a million times already. So, and then we're going to finish the sketch. Now, using two-dimensional objects, you can use those two-dimensional objects to remove or add material to your 3D object. In this case, we're going to use it to remove. So we're going to use this press pull tool. And I'm basically just going to go around, I'm going to select all my circles. When I have the press pull tool selected, it will automatically, I don't have to hit control or anything, I just click on the objects and when I'm done. Now, if I pull away and where there's no material, it's going to add material. See how it's adding, is it you keeping up with me here? So I'm adding, I'm doing the opposite. So yeah, it's just delay. Okay, so now I went down 5 millimeters, and where it comes in contact, -5, not okay. Where it comes in contact with the material, it's going to remove that material. Okay. So now we have, yep. Now we need to have the shaft, because obviously, you know, the bottom of this is going to be solid. So I'm going to go to the bottom, create a sketch on the bottom. And you would normally use a caliper to measure your shaft. And just to let you know, when you print your first prototype, it's not going to fit. Because printing the material, it's going to kind of, you know, it's going to go down and it's going to flatten out a little bit. So you kind of have to adjust a little bit for that. So when I made Kitty's knob, it took 2 prototypes to finalize that, but, so I'm going to say 4 millimeters. And that will be at the base of the shaft circle. I'm going to create what's called a construction line, which is a line that's actually not part of the drawing. I wanted to match it up with the bottom of this circle here. And the construction line is brown in color, so that you can see that it's a construction line. And then I'm actually going to draw another regular line going across the circle here. And I deliberately want to go over all the parts. And you'll see why in a second. I'm going to hit this check mark here. That's a new feature that tells me I'm done drawing, because else it's going to keep saying you want to add more lines. Using a distance tool, I want to measure 3 millimeters. Because I'm going to. And so what was going to happen here is, and something happened here. Hang on a second. Control Z, Control Z, Control Z. That did not go the way I wanted it to go. Why did you go in that direction? I don't know. Supposed to, the construction line should not have moved. Okay. Measuring a distance between this line and the construction line should be 3 millimeters. That should move this line. Yep, it did it this time. So now I'm going to use the trim tool to cut off this material, that material, that, and that circle. So now we have the key shaft bolt. Finish. I'm going to select the shaft. I'm going to use the push pull, go up into the knob 6 millimeters, -6 millimeters, because go the opposite direction. Where did you go? Where did you go? Where did you go? There we go. -6, enter. And now we have a very nice basic knob. Yeah.
So far across from AutoCAD, I was 20 years ago.
Yeah. Yeah, I looked at another CAD program and I opened it up and I had no idea even where to get started. It looked like you needed to be a rocket scientist to use it.
Sometimes they give you way too many capabilities that you don't need.
Yeah.
It's pretty.
This was made for, and the nice thing about these programs like Fusion 360 and others is there is a ton of YouTube videos and tutorials. And if you watch those tutorials, you'll see some steps that I've skipped that you're technically supposed to be to. You're supposed to do that, you know, like, you know, more construction, more restraints and stuff like that. So if you resize things, they resize properly. I skipped all that for this demo. I mean, so basically to convert this into a STL file, you go here and then you export, and then you're able to select a STL file. You give it a name, and this says I need to be on the cloud and things is offline for, you know, but I don't care because I already have the file saved. So basically you enter the file name, it will take a few minutes and then it will download in your downloads folder the STL file for your, now each time you do this, it's going to add a version number to it. So it'll be version 1, 2, 3, 4, 5, 6. So it's not going to override your existing one, so you make changes and you adjust it. All right. On Kira. All right, Ultimaker Kira is a slicer program, and there are other slicer programs out there. This one's free. This one actually came with my printer, at least an older version of it did. And I always like to keep this up to date. Keep in mind that if you have more than one printer, you want to make sure that you have the right printer selected when you do this. Let me go and open up, before we open up the knob that we just did, I want to show you a bigger object here. Show you some features of this. We'll rotate this. This is that knob I made for Kitty. So you can see there's different settings here that it defaults to. Standard quality does a pretty good job for a quick test print. This right here is done in the best quality possible, which is a tighter print, better quality, a little strong, and I made it a little stronger. Layer height is how high the layers are. Wall thickness, see this says the wall line count is 2. Let me go ahead and slice this because I want to show you what the software is actually doing. The preview slice, and you can see, let me do this. No. Okay. I don't want to move it. I want to select. If I go into different layers here, you can see that the wall here is 2 layers thick, and you can see that this honeycomb pattern here, what it's doing is it's only using 20% material, 80% air. That's called the infill. If I change this, the infill pattern will become tighter. You can also change what the pattern is. You can use lines, which will draw a grid. There's triangles, etc. So this gives the ability of using less plastic. If you want to make it stronger, you would use less fill. But if you do 100% solid, you can have some warping. Oftentimes, you would need to experiment with the best to get the best results. And there are people that just they like to experiment with these benchies and do like speed prints where they see how the fastest they can make the printer print one of these things. And things like that. You fine tune things and you can make printers do even finer print jobs. And if you don't have fine tune, it'll make it even worse. Another thing is the cooling and everything else factors in also. So you can see there's multiple layers here. And as I go down, you see where there's a wall here. It will have 2 layers. Now, the support structures in this one, when I printed this for Kitty, I did add support structures for the inside of the shaft because it's a big rectangular shaft and I did have material fall in. So let me show you what a support structure looks like. And there's several options for that. You got everywhere, or you can go wherever it needs to touch the faceplate. I'm going to use that. So inside here, you can start seeing that it's printing the support structure inside the shaft there. So that's holding up the roof of that shaft. It's a big rectangular shaft. And this right here is called a skirt. And what the skirt does is 2 things. It lets you see ahead of time if your adhesion's working properly. Adhesion is it's sticking to the surface of the printer. If your skirt starts messing up immediately, you know that you have to adjust the printer. The printer head has to be a certain distance from the surface of the bed. And this right here is the universal adjustment tool. Okay. Piece of paper. When you adjust the bed, you want to make sure that you adjust it so that this starts to have some resistance to the head. If it's stuck, what's going to happen is the print head is just going to smash it down there and it's going to drag her and move your part around. If it's too far away, it's just not going to stick to the surface of the bed. This printer here only has manual adjustments, and I had to recalibrate this because I brought it in the car. It got way out of whack. There are printers that have self-adjusting, but you still need to be able to manually adjust every now and then because self-adjustment will not handle large variations. When you do adjust these things, heat them up to the bed temperature. So, because if you do it as cold, it gets heated up it's not going to be the same. So always adjust it at 60 degrees Celsius for PLA or 80 degrees for PETG. Universal calibration tool. Let's open up that knob that we just created. Open, that's me. Demo knob version 1. So it's going to pop here, and for some strange reason, it puts it on its side. Okay, so I'm going to tell I want to rotate it over this. Come on. Nope, too much. Nope, too much. I find that the rotate tool sometimes a little finicky. There we go. So on this print, I'm going to keep the default settings. This is not going to have much infill because it's tiny. The print bed temperature for PLA 60 degrees is fine. Oh, by the way, some printers don't have a heated bed. You want a heated bed. Okay. That's there's no negotiating that. The default bed that this comes with is a magnetic plastic thing that's great. You can take it off and you can easily remove the part. Problem with it is adhesion. This glass bed is significantly better for adhesion. However, it's much harder to get the part off. So you have to let it cool down a little bit and then you wiggle it and pop it off. And the printer does come with a spatula thing, though I don't know how useful that is when it's on the glass. So I'm going to say 220 degrees for the PLA. And I'm just going to use the default other settings. Splice generates the P code. And then you would save it to the disk, or if you have a memory card, it will say save the memory card. I don't have any fancy attachments that allows me to go directly to the printer. There are Raspberry Pis that you communicate,
Octopi is.
Octopi, yes, he was telling me about it. I was like, oh, that'd be so cool. I don't have that.
Yeah.
So basically, I have to use the old-fashioned sneaker net, and so I get my card. It's a micro SD, so I pop it out of this thing and stick it upside down into the little and flip the printer on. Okay. Then I tell it to print from the memory card, and hopefully I select the right one, because I have the super large one, and I have the, okay, so this is the largest, the regular one. So the printer is going to start doing things. Right now it's cold, so you have to wait a little bit for it to warm up to 220 degrees Celsius on the extruder and 60 degrees Celsius on the bed. And this is a tiny knob because it's going to take 8 to 10 minutes to print that. So while waiting, does anybody have any questions?
Maybe they can't appreciate the fact that this thing is printing at a 1/10 of a millimeter in height. Each layer.
Mhm.
That's how thick or thin, I should say it is. So like that red box I printed, that took 7.5 hours. So if you're doing something big,
Oh, my.
yeah, come back the next day.
There are some
Yeah.
prints that will take days to print.
I did feet for a Tektronix TM 5000 series power frame, but I made them full length, 200 millimeters. It was 19.5 hours
Yeah, my longest,
for four.
my longest is like 35 hours. It's not bad, yeah.
That's hope. Hope it doesn't spaghetti.
Yeah.
And another thing is, when you work on a project like this radio here, I printed like 15 test prints. I initially started making just one design, and when I printed off, nothing matched. So it's like, okay, I'm going to start off one design. So first I designed the outer. Once I got that right, and I designed a little groove that goes here. Then I designed a little teeth that
Hey,
face
George,
like nuts.
Can you stop sharing your screen and then we can
Yeah.
see what's going on?
Yeah.
People at home can. Because at this point, you keep going
Yeah.
with
So,
your presentation, okay.
and let me tell you what the temperature is now. Temperature is at 175 degrees. Yep, 50 degrees Celsius on the bed.
Yes, for the Indian.
Now, PLI does have fumes, but it's nowhere near as bad as the ABS. I was printing some rocket stands, which took a couple hours to print, and I was printing them. I was mass producing them. I made 3 of them, and my office area I was working, it started to smell like plastic, but oh well. But anyways, let me pass these around. When you're storing the filament, it's good to keep it in an area that it's not too much humidity. So as the plastic will absorb moisture, which will cause it to not print correctly. The moisture will obviously, yes.
If you're gonna store rolls of any filament, but especially the nylons, PLA is not as bad as nylon. A food saver is actually your friend.
Yeah.
One of the vacuum sealers, just suck the air out, put it in the back bag.
Speaking of foods, make sure if you're gonna print something that you're going to eat off of, you use food grade plastic.
Yes.
They do sell food grade plastic to make Tupperware and trays and things like that.
That
Well-
also being said, make sure you purge some through the printer too.
Yes.
Yes. Yes.
Just
You'll
just
notice that
adding
when
to
you
that food
colors,
thing.
The printer will actually print a kind of like a test print along the edge here, and that's just to clear out not to get the nozzle to flow. And you'll see that the colors will change. So in here, there was blue before. Actually, I did a print earlier, so probably already did it. Yeah, right here. And you can see that there is a transition of color. It's gonna probably won't pick up a camera, but you can see there's a transition going from white to blue.
Put it on the table and I can get it.
Yeah. So. Now, let's say you want to print, you see that N3VQW sign here? There it goes. This is only a 1-color printer, so how do you think I did 2 colors? I was printing this way. I told it to stop after the 5th layer, told that I want to change the filament. So I changed the filament out to white. It ran a bunch of filament out to clear it out, which I thought was way too much. It wasted, by the way, and then started printing white over it. Okay. They do have 3D printers that have more than one head, different colors, or it could change the filaments out.
It's doing something and I've got it on camera, so you can.
Yeah, hopefully it's not
Describe
messing up.
And the scary thing is,
Yep.
General Electric is printing jet blades for their new, latest airplane engine.
Oh, at the high end, the laser activated titanium powder, you can get some really exotic parts out of it.
They actually also, 3D printing biomaterials. So
I was about to bring that up, yeah.
yeah, they're actually starting to learn how to print 3D organs. And I think they're starting off simple things like esophagus and things like that.
They did a child's esophagus. The
Yes.
child had a problem with the upper esophagus. They created a plastic esophagus that they then had cultured the skin cells from the child on there and were able to transplant. The child sadly did not survive very long, but it ended up extending the life of the child and proved that it is a viable technology.
I have no idea if this is messing up or not.
Well, it was a situation where the child
Yeah,
was
it-
gonna die and they.
It messed up, it gummed up. But anyways, if it was successful. It would have printed out. One of these.
Put it down on the table.
Yep.
and Take a look at it.
See, it,
Okay.
calibration was wrong, so it got spider webbed underneath the head there. Compared to the 500 times.
Yeah.
George, we do have a question online.
Yes, what's the question?
Rocky, go ahead.
It's more of a comment than a question. 2 things. First off, I found it very helpful for like printing a knot or something like that. You don't have to print the entire thing to test fit it. You can do maybe 20 layers so that the hole is there correct. Put it on, see if it works or not. If it does, start over. If not, make your adjustment, try again.
I was doing that when I was printing tests for my radios here, because when I was doing this component, this edge here. It was printing this way up. And I figured once I get past here, I don't really need to print anymore. Because I was needed to test fit the holes, screw holes. Because 8 hours. So I've actually, some of the touch prints didn't actually print out the entire part, only what I needed to print.
And the other thing you mentioned, well, Chezzy mentioned food grade. The issue, if you're going to use any kind of like raw meat or anything with one of these 3D printed things, additive printing leaves a lot of little nooks and crannies that bacteria likes to hide in. So it's not recommended for that type of application.
I was going to bring that up.
Yeah. And what I ended up doing, because I made a hamburger press out of it because I was bored, but what I found was just wrap it in a little saran wrap and you're good to go.
Yeah, there you go. Yeah. So another thing that's good, if you're trying to justify getting yourself a 3D printer for your ham shack, think about your honey-do list. There are probably some things on your honey-do list that you can say to your ex-wife, what is it? XYL. Not your ex-wife, your YL, or your old YL. You can tell, hey, listen, if you let me buy this printer, I could fix those cabinets or whatever.
It's an educational toy for the children.
Yeah, it's an educational toy for the children.
Yeah.
George jewelry hold his word and the napkin hold. his
Yeah.
word. You can test all those.
Yeah, you'll find things, you know, I got this wire rack for Christmas. It holds spools of wire. And almost all the pegs that hold the rods were broken. So I printed new knobs. And so this goes in here, there's a rod here, the wire spools are on them. So I printed like 6 of these. It's my Christmas present. And again, I mentioned the bookshelf. And these, never see these again once I fire them off. You'll find these on Thingiverse under disposable rockets. They're quarter A engines.
Oh, so you just bring
Micro?
Yeah. So you just shoot these off and.
Yep.
Any other questions?
Those are micro engines.
Yeah, these are the Estes quarter A's.
Yeah, micro.
Yep.
What is it, Thingiverse?
Thingiverse.com.
No, I mean, what's the,
Oh, disposable.
Disposable rockets.
Disposable rocket.
They also have these that go on the A size. You know, the regular size engines, so you can put them on the A or B engines. If you really don't want to see them ever again.
Yeah. it's called mosquito.
I have.
All right, anything else for George? All right, thank you, George.
Thank you.